Thank you everybody for joining us today for the Building Water Efficiency webinar hosted by Environmental Defense Fund and AT&T. Many of us are listening to this webinar today from large commercial buildings that have cooling towers up on the roof to regulate building temperature. Building cooling processes use up to 28% of a commercial or industrial building's daily water use. And that water use is precisely what AT&T and EDF set out to minimize. The two joined forces last May to find best practices for minimizing water use in building cooling systems. Their collaboration resulted in a water efficiency toolkit that could save U.S. buildings 28 billion gallons of water each year. Today, our presenters will give you an overview and demonstration of the resources in the toolkit. Our goal is that you will leave today's webinar ready to apply the water tools to your own organization. You'll be able to measure and manage water use, optimize building cooling systems, and start building the business case for water management in your organizations. We have a great group of panelists to guide you through the water tools today. From AT&T, we have John Schultz and Tim Fleming. John is AT&T's Director of Sustainability Operations. He's focused on embedding sustainability into the company's operations, products, and services while positioning information and communications technology, or ICT, as an important sustainability solution. John has held a wide range of positions at the company, including roles with the sustainability, external affairs, energy, corporate real estate, and IT teams. Also from AT&T, we're joined by Tim Fleming, a Senior Project Manager for Sustainability Operations. He works with John on the sustainability team and has been the lead on developing the technical water efficiency tools and resources that are being shared today. His previous roles at AT&T included corporate real estate and IT operations. From EDF, we're joined by Brendan Fitzsimons. Brendan is a project manager with EDF's corporate partnerships team. He currently leads EDF's work with AT&T to cut energy and water use in building cooling systems. Before joining the corporate partnerships team, Brendan was a policy specialist on EDF's National Climate Campaign. And last but not least, we have Bill Harst. Bill is an independent water management consultant with Harst & Associates. He has more than 40 years of experience in water treatment and was instrumental in developing the water tools that were created. Now, let me turn it over to John, who will explain why AT&T began looking at water.
Well, thank you, Hillary, and thanks to all of our attendees here today. You know, oftentimes when I'm having this conversation, people look at me funny and say, why is AT&T talking about water? And I think it's probably reasonable because it's not an obvious connection, but really it all started with our focus on resource efficiency. As you probably can imagine, we manage a large portfolio of buildings, and we're always looking to drive efficiency into those buildings. And we've been working on energy efficiency for years, but we realized that water is another important opportunity for us to drive the reduction of important resources and to drive energy savings as well. So we started to look at water, and our first step was to define our water footprint. It came in around 3.3 billion gallons of water. Now, that's a good starting point, but the big number really wasn't very instructive for us, so we dug deeper into that, and we realized that of our portfolio, 125 facilities represented about half of our water usage. That's a relatively small number, and that, in fact, over 30 of those were in areas of high stress. So we recognized that this was indeed an opportunity, but we wondered, why is it that this relatively small set of buildings was using so much water? It turns out it was cooling, and more particularly the use of cooling towers at those facilities. So that was our revelation, and we realized, in fact, this is not unusual. As Hillary mentioned, 28% of water use in typical buildings is for cooling. So this was our opportunity, and we decided to focus in on that, driving water efficiency in that cooling process. So with this focus, we began to work together with EDF, and we ran a series of pilots to test the water savings tools and to validate the business case for water efficiency, which can oftentimes be a challenge. And the results of those pilots were encouraging. Tim's going to talk about some of those details in a minute. But during that process, we realized something, and it was really a fundamental knowledge that the tools we were building certainly help our own water efficiency program. They were helpful for us. We've set goals as a result of this. It's been really fundamental for our use, but it really could be very helpful for other companies in similar positions. that are also driving towards energy efficiency in their own operations. So if you run a business that depends on having buildings run efficiently and making prudent financial investments, we thought this could be a set of tools that might help you in that journey. So we began the process of polishing these tools, trying to formalize some of the documentation. And really all of this was meant to be something that we could share publicly and help others build water programs and set their own set of goals. And that's really why we're here today. We're going to take a pretty detailed look at the content of that toolkit that we've developed so that you can apply them in your own business. But here's the trick, though. Much like our own portfolio, your portfolio of buildings will be unique, and there is no silver bullet, and you can't apply one type of technology, one program to your building. But the toolkit should give you some tools to start this conversation about water efficiency in the cooling process. Hopefully it'll give you some feedback about how you're doing and how that could be raised to the optimal level and what that difference looks like. And most importantly, perhaps, it'll help the conversation about return on investment. What are the potential savings of running water efficiency at the optimal level and how that return on investment could be used to build the business case. So with that, I'm going to hand it over to Tim, and he's going to talk a little bit about the projects and the toolkit. Tim.
Great, thanks, John, and hello, everyone. So as John mentioned, we conducted a series of pilots at a number of facilities across the country, and that represented different building types and used a number of different approaches. And we wanted a good mix of buildings that represented different climates, heat load on the building, varying makeup water quality, which is a primary determinant sometimes in your water efficiency, and gave us the ability to test a number of different solutions. Now, the first approach is what we call the technical approach. And we found opportunities here for improving water efficiency by primarily increasing cycles of concentration through the use of improvements such as softeners, filtration devices, and a few others. Now, if you're not familiar with the term cycles of concentration, that's okay. Just know that in terms of water efficiency, typically higher cycles is better. So, for example, again, talking about making the business case for this, which is very important. We have one cooling tower filtration system upgrade we put in, and it costs less than $100,000 to install, but it's already returning more than $60,000 a year in annual water and sewer charge savings. So that's paying for itself in less than 2 years. That's pretty attractive payback. So that's the dollar side. On the water side, we saw very significant drops in water usage with a near 70% reduction in sewer discharge and a 29% reduction of our water usage in the cooling system overall. So very, very successful pilot there. We also found the greatest water and energy improvement. We're talking about water, but we can't ignore the energy side as we talk about the water and energy nexus. But we found the greatest water and energy improvements occurring when we reduce load on the chillers and the towers by increasing our free air cooling. And that takes advantage of outside air when it's cool. So just think about opening your window when it's cold outside. And that provides some or all of the cooling in a building, depending on the characteristics of the building and what kind of equipment or the characteristics of the building. So while a complete free air cooling retrofit is typically very costly, we did find a lot of opportunities in our portfolio to repair or upgrade these systems where they existed. And an example here I highlight, we have a lot of these projects, but this is a small one to show you don't have to have a lot of investment to get some return. One example is we had a building where we made a $4,000 equipment upgrade to the dampers and the building automation system. And that's saving water, but it's also returning $40,000. So that's a great ROI on that project. So, we're a business and we have to attack this from a business case perspective. So, the dollars are important. And I do want to clarify that as we talk about these things, the technical solutions and free air cooling, the toolkit is not designed or intended to make any specific solution recommendations. Rather, it's designed to equip you with enough information so that you can evaluate each of your sites. As John said, they're all unique. Then you can have informed discussions with your vendors. In fact, at AT&T, we are using a mix of approaches, and not all buildings have opportunity for improvement. So you really have to evaluate each building on its own merit. Now, finally, you'll see listed here an approach we call operational, and that's just referring to increasing efficiency by treating the water with traditional chemistry, which is the more conventional approach. We really didn't see enough incremental improvement through that method to warrant a broader program. So we really keyed in on the two levers, the two interventions being on the technical side and the free air cooling. So the pilots were very successful, very encouraging, and overall we saw water reductions ranging from 14 to 40% at the sites that implemented either a technical or a free air cooling solution. Taking those results, then we were encouraged to set a goal for the company of reducing our 1 billion gallon annual cooling water use by 150 million gallons per year by 2015. The results also helped the team to estimate how much water could be saved across the U.S., similar results were achieved, and that's why we're encouraged to have other folks and organizations take these tools and make them their own. So in order to talk about those broader results, I'm going to let Brennan talk about that.
Thanks, Tim. As you all can imagine, EDF is really excited about AT&T cutting their water and energy use. But what gets us really exciting is thinking about scaling up these savings beyond AT&T. And these tools and resources that we're sharing with you all today can be deployed not just at companies like AT&T in the ICT sector, but actually to a broad range of buildings, ranging from sports stadiums, hospitals, office buildings, hotels, and other buildings in a broad range of sectors. We estimate that if buildings in the commercial and institutional sector improve their cooling tower efficiency, we could save 28 billion gallons of water per year. That's a lot of water. To help put it in perspective, you can think about trying to fill 400 million bathtubs a year, and those savings accumulate year after year. This toolkit can help your company or organization realize some of those 28 billion in potential savings. And as Tim mentioned, the term the energy water nexus, which I'm sure many of you are familiar with. So when we save water, we're actually also saving the energy used to supply that water, purify that water, distribute that water, and treat that water. Those are all significant savings. And with that, I'll kick it back to Tim.
Great, thanks, Brennan. So when we talk about the toolkit, it's comprised of a number of different tools, which you might use differently depending on what your role is within your organization. And they weren't necessarily designed exclusively for one audience or another, and you'll find that there's some overlap and different uses for them depending on what your role is. So what I'd like to do now is just take a moment and briefly touch on what these individual tools are. And then we're going to dive into, I'm going to open up the Excel-based water map, which is really kind of at the heart of the toolkit. So I'm going to walk you through the tabs in the Excel spreadsheet. But first, I wanted to touch on each of these elements. So, right off the bat, the water map tool, that is the Excel-based tool that integrates the scorecard functionality with an efficiency and savings calculator. And what it does, it provides you a single location to collect your building performance data and then also develop savings estimates, which could then be used for, say, a water efficiency business case. So the scorecard is the tool that is used to create visibility for water performance at the facility. And for the facility managers, this helps them to evaluate areas of opportunities for improving water efficiency. And for leaders, it's a great way to provide a structured approach to track progress and compare performance against the portfolio. Because by sharing grades across an organization, this process creates a powerful tool to raise visibility. And, you go back to what John was commenting on, where we started with what's our water usage and where are we using water. And, as we've gone along this journey, it's the visibility, it's the awareness that really we're seeing driving results. So that stimulates sharing of ideas, and it also leads to higher performance. Can't manage what you don't measure, and you see improvements in the scorecard grades. So the other component of the tool is the efficiency component, and that utilizes the building data that is input into the scorecard. And we also use historical weather data we pull from NOAA, calculate potential savings based on freer cooling opportunities, and then efficiency improvements through increasing your cycles of concentration. So all of this comes together to help you build a business case so that you can actually achieve those efficiencies that you're striving for. Now, the Water Scorecard Guide is another component of the toolkit. Now, the Water Map is an Excel-based version of our own Water Scorecard. However, if you wanted to design one of your own to meet your own organization's specific needs, you could certainly take Water Map, but we have created the Scorecard Guide, which helps you develop your own scorecard or tailor our own water map to your needs. So if you wanted to make it a web-based or use some other tool, we have a guide to help you walk through each component and how you might set that up to set up your own scorecard. We also have a couple of infographics, and they are just two clear, easy to understand graphics, and they help your leaders initiate the water conversation, drive awareness, and encourage participation by your employees as well. We found these to be pretty useful. So the next group of tools is really the water audit templates, kind of a standalone, because when, in order to build your program, you're going to have to know where your water is used, and these templates can help you assist in defining the water profile of each building. So it's a really good place to start in capturing information that you could then input into the spreadsheet or your own scorecard. And finally, in the toolkit, we've developed a series of training resources and technical references, and Bill had a big hand in that, so I'm going to let him talk about those.
Very good, Tim. Thank you very much. Well, as you've explained very well, the major opportunity that we identified in this project was in improving overall efficiency for cooling tower operations. And as anyone may know from working with cooling systems, building cooling systems, you quickly understand that this consists of a fairly complex mechanical system comprised of many different components. And in addition, you also have the complexity that's added by the water quality that may be present in your area for use in the cooling system. So these are all very technical topics, and sometimes folks who are just getting started need some help with understanding the terminologies and also the methodologies by which these mechanical systems operate to achieve the ultimate goal of maintaining the temperature and humidity in the building. So to help you with that, we've developed 3 technical resources that we feel are specifically focused on optimizing the performance of the cooling tower system. And these are 3 resources that are educational tools, but they're also practical tools in that they serve as a useful reference as you work through the opportunities that may exist in your facility. The first one is a series of 12 videos that can be used by anyone in your organization who would like or would need more information on the fundamentals of how a cooling system works. And this would hold true for anyone who may be just starting out, who needs just a basic understanding of cooling system operations, or as a refresher for someone perhaps who is, needs a little more updating on some of the specifics of cooling tower operations and other mechanical components of the system. The videos focus on how all of these cooling system components can be managed so that you minimize the use of water and energy and the consumption of water treatment chemicals. Basically, we focus on some of the fundamentals of cooling tower operation. We also look at mechanical chillers and how they work. We talk about cycles of concentration and how that applies to improving efficiency of cooling towers. We also discuss some of the water treatment technology basics that are required in order to maintain the cooling system. So a very useful reference there. The other one was the Cooling Tower Efficiency Guide. Now, cooling tower operations provide a tremendous opportunity for water efficiency improvement. Actually, a cooling tower, that's the purpose of a cooling tower, is to conserve water. In order to get optimum use out of the cooling tower, we need to find ways to enhance its efficiency from a water consumption standpoint. So to do that, it's critical that we understand the cooling process and the role of the cooling tower in the building cooling system. So this technical guide will assist the facility managers and others with the operation of their cooling tower systems and how they can improve their operation with the goal of reducing energy, water, and chemical consumption. And Tim will be showing a little more of that later on as far as how that can be best utilized through examples. And finally, we've put together a cycles of concentration estimator. You've probably heard us refer to cycles of concentration along the way here, and Tim accurately points out that higher cycles improve efficiency of cooling tower operations. So you really want to operate your cooling tower at maximum cycles of concentration, but that said, you don't want to over-concentrate run at higher cycles of concentration that is prudent in order to protect the system from some of the problems associated with scale and corrosion and microbiological growths. So the question becomes, well, what is that optimum cycle of concentration? Well, for those of you who have looked into this to any extent, you probably understand that water quality varies throughout the United States, and it's very unlikely that any 2 facilities are going to have exactly the same water quality available to them for use in the cooling tower. So cycles of concentration will vary from one point to another, and what we've done here is put together a tool that will allow you to input the water quality characteristics for your facility, and then it automatically will go ahead and calculate a recommended maximum permissible cycle of concentration using a traditional chemical treatment program. So you can then take this information and compare it to the current operating conditions for your cooling tower to determine if you have opportunity for water savings. So it's a nice, handy tool. And again, Tim will be explaining and showing an example of the cycle of concentration estimator. So those are the three tools. We recommend that you take a look at them and use them to your advantage when working with your building cooling system. So Tim, I'll let you take it from there.
Great, thanks. Just one more slide, and we're going to jump into the WaterMap Excel tool. But we just put this together to maybe help frame up how these tools might be used depending on what your role is with the organization, and you'll see some overlap. You see some of these tools in both of these roles, but I don't want to spend too much time on this slide. We'll come back to it because I want to spend some more time. I want to make sure I have enough time to spend in the Excel. It's probably what you're here for. But if you're a facility manager, you want to use the training resources Bill just talked about. You want to assess the building water usage. You're going to use the water map tool to evaluate cycles concentration, efficiency opportunities, and then you're going to implement solutions based on whatever intervention you think is appropriate and whatever lever that you're trying to use to improve efficiency. And the organizational leaders trying to generate awareness amongst the organization, use the infographics for that, and you can also use the information taken that the facility manager has gathered within the scorecards for on the performance side, and then you're going to build a business case. You're going to have to put all this information together. The tools help you identify the financial opportunity there, and then that helps you fund business cases to actually achieve the results. So with that, I'd like to switch over to the Excel spreadsheet. When you first get into the spreadsheet, it's a protected workbook. There's no password on it. It's just protected so you don't inadvertently change something or somebody doesn't inadvertently change something. What you'll want to do is unprotect the workbook, and that also frees up the tabs at the bottom there. I'm going to skip through the introduction. I think we've had plenty of introduction, so let's just jump right into it. The first tab is the water scorecard input. Here's where you are going to enter the data that will result in the grade and your overall scorecard output. So I'll just walk you quickly through these sections. Now, these are a mix of free text fields and drop-downs. The drop-downs typically either drive scoring or savings or efficiency calculations. But some of these are just to capture data to the facility and don't necessarily have any integration anywhere else in the tool. But this first section, probably the most important field, is going to be this closest city field, and this is a drop-down, and this is where there's a lookup that pulls from our historical NOAA data. We have over 200 cities in here across the U.S., and we have 100 years of averages for temperature data, and that helps do the calculations for where the free or cooling opportunities may rest. So you'll probably find, I can almost guarantee, wherever your facility sits in the U.S., you'll find a city in this drop-down that is close enough that it approximates the typical climate conditions at the site that we're talking about. So that's the building information. This next section is the water consumption, and the whole point here is water efficiency. So we're trying to drive a reduction in our water consumption, so we want to enter the historical water usage for the past 24 months, which hopefully show a downtrend. Now, this could either be the facility level data or the makeup meter data, and there are points associated with that. Now, this next section is the water audit and projects. Now, really for us, the purpose of the scorecard is kind of twofold. We want to capture all information and understand the performance of the building, but what we're really trying to do is we want to drive action. We want to reward action. So we assign points. We give you more points if you have taken action towards water efficiency or water conservation. So we start here by asking if an audit's been performed and what, if any, projects have resulted from the audit. And you don't see the actual scores here, but these are drop-downs, and you'll get more points depending on each of these answers has different points associated. So if I've done an audit within the last 3 years, I get the most points. If I've never done it, I get no points, and I get something in between if it's yes, but it's been 3 years ago. That's just an example. Throughout this spreadsheet, you could go through, change the questions, change the answers, and change the actual scoring and the weightings that are associated. We'll look at the output and the scores here in a second. So that's the audit and the projects. The next section is the inside water use. So we're talking about cooling in our intro a lot because we found that's where the biggest opportunity was. But the scorecard is not just a cooling system scorecard. It's a total, hopefully a total building water usage scorecard. So we ask about inside water use. Do you have faucet aerators? We ask about low flow toilets, and you, of course, get different choices. You have different choices, and you can get different points depending on what your answer is. So that's kind of a common theme drop down. We actually ask about outside water use. Landscaping can account for up to 15% of the total site's water use, depending on the characteristics. If it's a large campus with a lot of irrigation. So we ask you about your outside water use, and we have different choices for the user to input. And then we have a collection of other opportunities, we'll call them. So this is just a series of yes or no questions, and you have water-related goals in your annual performance review. I can tell you that this would be hard-coded for us because we have water-related goals in our facility manager's performance reviews. We don't even have to ask the question. We ask about sewer credits. Have you identified rebates? Have you implemented any kind of water efficiency innovations at your building? All of these have points associated with them, and it starts driving the questions, even if they haven't done these things, right? The facility manager starts thinking, maybe I haven't thought about that, or I need to find out more about that, right? So a lot of times it'll start the conversation. Now we get to the bottom. This is the last section for the entry, and these are a series of questions around the cooling system. This is kind of the heart of evaluating the cooling towers and the opportunities for free air cooling. Now, if a site doesn't have a cooling tower, you could just answer no and skip the rest of this section, but the rest of the workbook really wouldn't apply. But you could still get the benefits of the scorecard and all the scoring. You just wouldn't use the efficiency calculators towards the end. But if you do have a cooling tower, you're going to want to capture all the following information. Now, a few of these fields may not affect the score or the calculations, but they are helpful in aggregate reporting. And they have another side benefit, and that's ensuring that your facility manager knows what these values are. Because I can tell you from experience, there are a number of questions here, and I think generally would expect most facility managers, or at least their team, the engineers in the building, to be able to answer these questions. So if they don't know the answer, this encourages them to go find out. So we ask about what their current cycles concentration is. We recommend a target of 10. As Bill said, there's an optimal level. Generally speaking, we think that's a good target for cycles concentration. We ask about what water efficiency efforts have been completed, if any, at the site. This will be important for the free air cooling, actually for the entire exercise, but understanding what the peak load on the chillers is in terms of tons and what the total cooling capacity of the chillers are. We ask about chiller efficiency. So this gets, technical. You're going to want your technical folks to answer these questions. This may not mean much to a number of you on the phone. It certainly didn't necessarily mean a lot to me as a non-engineer, but after working with this for some time, we realized that these are the critical inputs to determining what the opportunity is. So there are chemicals used. We ask about costs. We have cost inputs here. We have unit inputs in terms of electricity, water charge, sewer charge. We have a water treatment cost line item, for example. Beyond chemicals, you may actually have a service contract, and so this gives you an opportunity to assign a dollar value. So we're trying to get it specific enough that it is useful to give you meaningful outputs that you could actually use. You could even go further. You could go deeper if you wanted to. So this just gives you an idea of all the different inputs. So you put all this information in, and then you jump over to the next tab, and then you have a grade. So from me monkeying around and choosing different things, I've come up with a total score of 77, and my overall grade is a C+. So probably not that great, and I have some building information here. And it gives you a chart, shows you the category scores. All those questions are rolled into these categories, and you can see where I scored well, maybe where I need to take a focus on improvement. It's all transparent with the way it's calculated. Each of the categories has a different weighting, and based on my answers, I get certain points. And then those points roll up into an overall score, for this example, 77. And then at the bottom, it shows you how the chart is derived based on the grading. So this tool is designed for a single building view. You could have all of your facility managers complete this tool and then aggregate these into a larger report and then build a leaderboard and maybe actually have a little bit of healthy competition going amongst your facilities, which we found actually has been very beneficial and useful. So that's the scorecard function, and you could stop there. You could say, you know what, I just need to have the inputs, maybe modify it, tailor to use, and then get the scorecards, and that's great. I think you'd see a lot of benefit, and that's a great first step. Now, if you have the cooling system information in terms of chiller and other metrics, you could move on, and then the next page gives you how much electricity, water, chemicals can be saved, and along with their associated dollar savings based on increasing cycles concentration or free air cooling. So this is the information that you're going to want to use in building your business case for your projects, or just setting your conservation goals. And this tab you can see is broken into what my intervention. So cycles of concentration increase, and if there's a potential from free air cooling. And you can see the different values here as far as units and overall dollars. So this tab actually is just a summary view of the next tab where the real detail gets in the real formulas. And again, we built it so it can be transparent and you can modify it to your own purpose. But this is really probably where you want to stop if you want to just take these numbers and then aggregate them into a business case. If you want to get deeper into the formulas and the details, we move over to the next tab, which is the water efficiency calculator. And you'll see the inputs. There's no entry on this screen. This is all taken from either their calculated fields or they are entries from the scorecard on that first tab. So we have our inputs here, and then we start getting into a lot more detail. We have the equivalent full load hours on our chiller, what the opportunity there is depending on whether we have an economizer or not, what our current hand cycles might be. We have chiller efficiency numbers. We have calculations on the cooling tower load, and all this informs the output below where you see you have your existing and enhanced values and what the overall change might be for any of these dimensions, be it the cost data or the actual unit data, depending on the area we're looking. So, really, regardless of what the intervention is, you can see where the opportunity lies, and this gives you the detail to give you the confidence to support your case. Just real quickly, I'll see if I can, I'll unprotect this sheet, just so I have to unprotect it so I can click in. And you can see that, there's the formulas here, up here in the formula bar. So just to know that if you want to take a look and make sure, if you want to validate on your own that you feel comfortable with the way these things are being calculated, you have that opportunity to do so. All right, so the next tab, moving on, is the cycles of concentration estimator. And Bill's already talked about, but here's a view of it, and this gives you the opportunity to take your makeup water quality values, input it here, and it will return what the recommended maximum cycles is for traditional water treatment, chemistry using conventional water treatment, chemistry, and what your limiting factors are. And we actually have a little handy guide here embedded in the document that you can read to walk you through what these values mean and how you might use them. The next tab is the chiller load data, and what this tab is for, this is where the weather data gets populated, but it also offers you a chance to modify the operating profile of the building in terms of hours of operation. So you can select and deselect these buttons if your building doesn't operate on the weekends or it gets shutting down. You reduce your load on your chillers, say at 6 o'clock, admin building, that type of thing. So it gets you to really sharpen your pencil on what the equivalent full load hours might be for that given site. So you have an opportunity to figure it even closer to even more flexibility and variability in how you can modify the values. It shows the load profiles for no econ and full econ. Those values could be changed, and it gives you a nice little handy chart or visual. You can see that we're operating. It shows you the city that we chose up front on the first tab, and then all the associated weather data is here below. There's lots of data on this tab. The last tab here is the terms and definitions, and that is just a few of the values that are asked for up front or referenced in the spreadsheet. It gives you a definition. You know what you're being asked for. It's not comprehensive, but it touches on all the main components and the main pieces of the spreadsheet. And the last thing I'll show you in the tool is, now that I've unprotected it, I can just right-click here and unhide the tabs. The EFLH, the equivalent full load hour study data, that's the NOAA data. Probably wouldn't want to make any changes to that, although you could if you wanted to. But the list sheet, that's where all of these lookups are. That's where all of the scoring values, all the questions are, and all the answers. And that's where you get into that sheet to make the scorecard your own, change the questions, change the scoring. I encourage you to take the toolkit, download it, and start playing with it. We do encourage you to make it your own. And so I want to jump out of the Excel spreadsheet here and go back to the PowerPoint. So hopefully, as I walk through that, you are better able to see how you might these different piece parts might be used depending on your role and how the tool fits into the sort of broader water efficiency program. And with that, I am going to hand it back over to Brendan.
Great, thank you, Tim. So we know that while a lot of companies will make the investments in these environmental efficiency opportunities because it's the right thing to do. A lot more are going to do it if they know it's going to improve their bottom line. So that's why having a strong business case is so important. So I just want to talk through in a little more detail the components of the business case for this, especially as it relates to water, because we know that water efficiency business cases typically aren't as strong as energy efficiency business cases. So when you're building that water efficiency business case, it's real important to make it as strong as possible and capture all those potential savings. And as you can see from the materials that Tim has walked through, you can see how all the tools we have here allow you to calculate all those potential savings, from your water savings, your sewer charges, your chemical costs, and your energy savings. So obviously you're paying for the water that's coming into your facility, and it's important to keep in mind that those charges have been going up and are expected to continue to go up. So the value you get from those water efficiency investments are going to be increasing over time. You're also paying not just for the water that goes into your facility, you're typically paying for water leaving your facility through your sewer charges. And by improving the efficiency of your cooling tower operations and reducing that water use, you're also going to be reducing the water that's going down the sewer. And you're typically paying more for your sewer charges than the water going into your facility. And additional savings along these lines that might not be as obvious are the chemical savings. So the more water you use, the more chemicals you have to use to treat that water. So the more efficiently you can operate your cooling tower operations, you're going to reduce the chemicals that you need to use to treat that water. And finally, on the energy side, as Tim pointed out, by taking advantage of free air cooling opportunities, you dramatically can save not just energy, but also your water, sewer, and chemical costs. One point I'll flag, during the course of this project, AT&T expanded how they calculated the business case for free air cooling efficiency investments. Initially, they would calculate the energy savings. As a result of this project, they recognized there were some additional water, sewer, and chemical savings. And when they factored those additional savings into identifying projects that would meet their internal hurdle rate, that helped a number of additional projects get over that hurdle that otherwise wouldn't have made the cut. These were the tools that were used to help build that business case. It's real important to think about all those different components to try and build as strong a business case as possible. And as Tim mentioned, if you haven't already done, I'd encourage you to download the full toolkit and take a look at it. I'd also encourage you to stay tuned to our website for additional updates on the tools and resources. And finally, I'd like to ask your help as you're using the tools, and if you find them helpful, please share them with colleagues, peers, and others who could benefit from using them. With that, I'd like to thank everyone on the call for taking the time to join us today, and now we'll open it up to questions. Thank you.
Thanks, Brendan. So we've got time for a few questions here. The first question we've got in the queue is one for AT&T, and it's, what processes did you follow to set your water goals, and how are you tracking progress against that goal?
That's a good question. I'll take that one, Tim. You know, you want to be sure before you set a goal, right? So we focused on the top 125 water-consuming sites. You know, John talked about those when we were identifying our footprint, and through our assessment and our audits, we found that these sites were the highest consuming water sites. And they're basically our scorecards, our primary scorecard sites. So then what we did is we used this toolkit, really the Excel spreadsheet or a version thereof, to aggregate the data to estimate what the reductions could be achieved, say, over the next 3 years at those sites. And from the pilots, we were encouraged by that range of 14 to 40%, and we feel like we can reduce our cooling water usage by 15% across our portfolio. Because, like I said, not all buildings have an opportunity, and where those opportunities exist, they may vary in terms of what the actual reductions could be. So we feel that a good, strong goal for us is to reduce our cooling water by 15% across the portfolio, and that equates to 150 million gallons saved at the company. Now, in terms of tracking, we had a side program that was associated because we said, well, we have to track all this. And again, making sure facility managers understood what their water usage was and making sure we could track towards the goal, we implemented a program to ensure that all the sites have makeup and blowdown meters so we can track usage. and facility managers know what kind of water they're using. And, of course, that's a good proxy sometimes for recycled concentration. It also has another benefit. It gives you the ability to receive sewer credits if you don't already have them in place and they're offered by your water provider, your municipality. You're going to need meters in place in order to capture those sewer credits. So we're actually seeing a side benefit of putting the meters in place where we didn't have them before.
Great. So our next question builds on that. So AT&T is obviously adopting the recommendations that are being put forth in the toolkit. Are there any other companies that have gone ahead and begun to use this toolkit in their operations?
Hi, this is Brendan. I can take a crack at answering that, and the short answer is yes, and it's a good question. For your company or organization, it helps to know that others are using this. And John, Tim, and I actually did a presentation similar to this summer to fellows in a program that Environmental Defense runs called Climate Corps. And this program matches MBA students with companies, and the fellows, the Climate Corps fellows, help identify environmental opportunities and builds a business case for them. And during a call this summer where we talked about these tools and resources with the Climate Corps fellows, one of the fellows in a company that was CA Technologies, it's a software company, participated in the call going over the tools and went back to CA Technologies and adapted the tools to do a water audit and use the water scorecard for CA Technologies, and they're going to be rolling that tool out this fall. It's a tool that's being used, and I'll also mention that for companies and organizations on the call, that Climate Corps could be a great resource for them. It's a program that's actually helped identify 1.3 billion savings for companies and organizations over the last 6 years. So, in fact, a potential fellowship could be using these tools and resources at your company or organization. These are tools and resources that are being used.
Fantastic. How did you get executive approval to make investments in water efficiency? As we talked about, water is a lot of times less expensive than other utility payments. So how did you go about convincing executives that this was a good investment, and is the business case really competitive?
Hillary, I'll jump in. This is John again. That's a challenging question, right? I think that's an important piece of success with any of these sorts of efforts is getting the attention and approval of executive sponsors. It's a competitive space too. As I mentioned in my opening remarks, energy is, the long pole in the tent, if you will. It seems like because of its cost, that oftentimes, companies tend to energy as they probably should. It's a big one. But water is not one that should be ignored. And usually, the pushback you get is cheap, right? Why are you bothering me with something that's so cheap and has such a relatively small impact? I think the answer is that it is such a local issue that in some areas, water availability can be perceived as a risk. And certainly for those who are trying to support their local communities, water efficiency is an important topic to be able to discuss locally. So I think there's some of that going on. But at the end of the day, good executive support, it really does require a competitive business case. And so I think that's the second half of your question was, is it really competitive? This is the point of this toolkit, was to identify ways in which to dig into the numbers to make it competitive. And here at AT&T, we've got a very clear line about what gets funded and what doesn't. And this tool was able to get, as Brendan mentioned, a portfolio of projects to the point where they are fundable. And so the answer is yes. You do have to look at it differently. You do have to look at it from a fairly broad perspective to include water, energy, chemicals, all those things we've talked about. But in the right place, in the right building, working together with the right vendor that has an appropriate technology or appropriate service, it can be made into a competitive business case. So I think it's the combination of kind of getting visibility to the local issue and having kind of that community-based engagement piece of it, but also working to get the numbers right so it can be competitive financially. So that's my take.
The next question in our queue is about a different relationship that facility managers have. It's their relationship with the vendors that work with them on water treatment. And do those vendors see this toolkit as an opportunity for them, or do they view it as a threat to their business model?
This is Bill. Sounds like that's related to water treatment technology, so maybe I'll take that one. Actually, it's a very insightful question because in traditional water treatment programs, the vendors focus primarily on the importance of maintaining clean heat transfer surfaces through minimizing scale deposition in the chillers and also controlling corrosion, and point to the importance of microbiological control for making the cooling water sanitary. And certainly those are important points, and we don't want to diminish the importance of that or make it appear that we're not emphasizing that should be continued. However, there's another element to cooling tower operations that sometimes the vendors don't discuss or bring up, and that is the importance of operating the cooling tower efficiently with regard to water consumption. So what we're hoping we can help with here is to point this out to facility managers and help them gain a better understanding of ways in which cooling tower operations can be improved from a water efficiency standpoint, so that they can have intelligent conversations with the vendors and perhaps even challenge them a bit, asking questions about, well, how does your treatment program help us save water? We understand, about the scale corrosion and fouling issues, but does your technology help us save water? Is it a viable way for us to reduce our water usage here? These are topics that aren't often brought up by the vendor. They're not going to bring these issues up all the time, so it's important that the facility manager be aware and have the knowledge and confidence to, bring this up and challenge the vendors and get a good working relationship so that you accomplish all those goals. So it's moving in that direction.
Yeah, so if I could just add on to that, from AT&T's perspective, the water chemistry game, it's complicated, and you look at all these values, and it's hard to arrive at a common opinion quite often. Bill and I like to joke that the water treatment vendors are like economists. You really can't get them in a room and agree on anything because they all have their different perspectives on what the right interventions or what the right mix should be. So it's quite a challenge, and we feel like the best weapon in the arsenal for your organization is making sure your facility managers have as much information and education and are informed as possible, so that when they go in to have these conversations, it's not just handing it over to your treatment vendor, that you're making sure that you're addressing the water efficiency and that you feel comfortable with the program that's being implemented at your site.
The next question we've got in the queue is about the water scorecard guide, and specifically the piece in there about water aerators on faucets. And it's recommended in the guide that these aerators are only used in high occupancy buildings with faucets that receive frequent use. So this question is asking why that is.
This is John. I'll jump in here, but everyone else can feel free to add perspective if they have it. So I think it's a good question. I think what it also touches on is the breadth of the scorecard. You can see the scorecard really does touch quite a few different topics. And so I think at a fundamental level, we saw great results from using the scorecard just to raise the awareness of the issue. So the question that you asked, I think, is very appropriate and shows how the scorecard can stimulate some of these ideas. The reason that the aerators are listed there is that it is a relatively low-cost way to go in and retrofit an existing faucet and reduce the amount of water that's used in that inside water usage loop. And so it's got a nice, pretty competitive financial return on investment, which, as we mentioned, is part of the key to making a successful water efficiency program. So that's why it's on the list. The reason that the note about where it's most appropriate to use it is in the process of building the scorecard, we worked with our friends in the Environmental Health and Safety Organization to get their feedback about how they deal with water issues. And one of the points that they made very clearly was that you don't want to have the aerators in use in a place where the water could be still for a long period of time, because various things could start growing in the water, and that could become an EH&S issue. So they made very clear that it's appropriate in high traffic areas where lots of water is flowed through the faucets themselves, but not appropriate for areas of low traffic where the water might accumulate and stay for a while. So it's really a tie-in to make sure that the water is healthy and good to use, even with that kind of flow restrictor technology on the faucet. So that's my bit on that. Any other comments from the crowd, or should we move to one more, Hillary?
Let's take one final question. How often do you recommend doing the grading on each of the facilities? Is it monthly? Is it annually? What does AT&T do, and what is the recommended pacing?
Yeah, I know we're short on time, so I'm going to just give you the quick answer. We do it annually, but when we don't just refresh the data, we feel annually is sufficient frequency, but we also evaluate is are the portfolio of buildings being scored the right mix as buildings improve their performance, and they've done everything they pretty much can do, and they're scoring A's. We move them out of the mix, and we add maybe some underperforming buildings in. So annually is fine. Maybe a semi-annual, we can move to a semi-annual, but we're doing every year.
Thanks, Tim. I want to thank all of our panelists for speaking to us today, teaching us about the toolkit, and also thank you to everybody who's joined us. If we didn't get a chance to answer your question, we have captured all that have been submitted, and we'll try to address them in a new FAQ section that will be posted on edf.org/ATTwater. Thank you again for joining us, and we encourage you to adopt the toolkit and jumpstart water savings in your own organizations. Have a great day.